So today we're going to look at a way to model and animate DNA. So this may come up in a project that you're working on, and there are lots of different ways you can make DNA. It depends whether it needs to animate, how it needs to animate, whether you're showing some particular action or not. You could use something like molecular Maya to bring more accurate DNA into your scene, and particularly with the double-stranded DNA kit. That is a really great tool for making natural motion of something like this. It's got some functionality for pose-to-pose animation and for doing things like cleaving. But what we're doing today is something different. We're making sort of more illustrative or schematic DNA. So just to show you what we'll end up with here today is just a strand of DNA that unwinds and then splits open for, a primer to be attached or replication or something. So it unwinds, opens up, and that's it. So let's talk a little bit about DNA and its structure. DNA is composed of two polynucleotide chains in the form of paired helices. So these spirals that we see here. And they coil around a common central axis. And so each helix, as you can see here, is made up of repeated units called nucleotides. But let's talk about the measurements a little bit. The radius of the helices together is about 1 nanometer. So I'm treating each Maya unit as a single nanometer. And so the pitch is about 3.4 nanometers. And what does the pitch mean? So the pitch is the distance from the top of one peak here to the next. So it's a single turn of the helix and winding up in the same spot. And that's about 3.4 nanometers. And what we should see are about 10 base pairs per turn. And so here, if the turn starts here, 1, 2, there's one back here, 3, 4, 5, 6, 7, 8, 9, 10. This could be a little tighter, actually. This is just maybe under 10. It's about 10, so we'll stick with this, but because we're using MASH, we can increase the number of instances of this object here. So one thing that people often get wrong when they're illustrating or modeling and animating DNA is the direction of the helix. So the helix can either be right-handed or it can be left-handed. And the type of DNA that we're dealing with, bDNA, is almost always right-handed DNA. And so the way to remember this is to hold your right hand in front of you with the palm towards you, curl your fingers in a bit and stick your thumb up. So the strand should go up and to the right. The other thing that is often overlooked are the major and minor grooves. The helices form a major groove here and a minor groove here. And then they go back and forth on either side. And this one is about 0.22 nanometers, and this is about 0.12 nanometers. So how do we get that? How do you get the curve to do that, to form, or the helices to do that, to form these major and minor grooves? Well, that has to do with the angle of the base pairs. And I have to admit I'm fudging it a little bit here. So you can see that my base pairs are not meeting at a perfect straight line across in the middle here. It's really probably more accurate to have them coming off the sugar phosphate backbone at an angle, but we can get the same effect by angling them here in the middle where they meet. So the way that I've done this is to make one helix and duplicate it and rotate it. But if I go into the replicator, and that's what's making the second helix, so if I rotate this down to 0, you can see they're coincident. And then if I go all the way to 180 and look at it here, this is often how you see DNA represented. You wind up with equally sized grooves. So let's see how we build this in MASH now that we have all our measurements in mind. And we'll start with our base object. So I built a single nucleotide out of a simple shape, and of course you could make this more or less complex. The way that I do this with MASH is I make a group object and then have shapes within it. And the reason for this is I can then swap in different shapes without having to re-instance something. So for example, you can see that I have a polygon sphere in here too. So if I unhide that and let's say hide that cube and then turn the mesh back on again, now it's got spheres. So we'll select the whole group. And one thing to note is that the group is sitting on top of the grid right at the 0, 0, 0 point, and its pivot point is at its base for the whole group. And now we're going to go to Mesh, create Mesh Network, and we'll create an instancer mesh. The default is a mesh mesh, and the distribution type will be linear. Of course, we can always change this after. I'll apply and close. Now you can see that when I set this up, I probably should have set it up along a different axis. These are going along the distance here in X, and there are 10 of them. I really want this to go along Z, so we'll just change the distance in X to 0 and change the distance in Z, or the Z offset, to 20. It's probably honestly better to work in X because Mesh seems to always default to the X axis for many of its functions. But since I started this way, I'll just keep going. I'm going to change these numbers a little bit just based on my past experience. So we have 60 repeats of this, and I set it to go 21 unit. And now we can rotate around Z, so we can start to get our spiral here. We're forming our helix. So it needs to go around more than this, and earlier I found it was 2400 to get the number of base pairs per revolution correct for the pitch of the DNA. Now it looks a little weird, right? Because the angle of the backbone segment is not correct. Now I could solve this in one of two ways. I could go back to the original nucleotide object that I instanced into the mesh. I'm just going to unhide it. And I could rotate it, right? So if I rotate this, then the mesh itself will rotate, and I can angle it like that. And that is not a bad way to do something like this in many cases. But for me, I actually want to animate that rotation later on once the DNA unwinds. So instead of doing it to the instanced object itself, I'm going to add a new node to this new mesh. I'm going to save my scene because my will crash. And I'm going to add an offset node. So in the offset node, we don't want to offset the position or the scale. We really just want to offset the rotation. So we'll leave that up, leave these two things at the default. And we want to, I think, offset in Y. Is that right? Something like 25 minus 25. Maybe it's 125. Yeah, it's closer to that. 115. Yeah. And so the good thing about this is we can animate this either by actually animating the value in this attribute itself. We can animate the strength if we wanted to rotate this way. But we'll deal with that later on once we start the animation. Save file. Okay, so what else do we want to do? We've got the first strand working, so now we want to make a duplicate of it, and to do that, we're going to add a replicator. So the replicator does what it says on the box. It just makes duplicates of your mesh network up to this point. So if I just say 1, you can see it almost does, and we're getting the major and minor groove here. And this is one way you could do it, because the offset by default is -2, and if we wanted to, we could get the offset just right, so we get our major and minor grooves. Those are kind of equal. But I found it's actually easier to do that predictably by not using the offset in Z, but instead doing a rotate in Z. So I'm going to rotate this around, and remember before I did either 120 or 133 degrees. And then that forms our major and minor groove. And there we go. We've got what we need. But let's say you were working on this and you realized you needed something longer for your shot. You can actually go back to the original distribute node, and we could change the number of points. So let's say we want to double this to 120. So it's got 120 nucleotides now. But then we have to double the Z offset to 42, and then double the number of turns to 4,800. And now we just have one that is double the length. Okay, so next step is we want to start on the animation. How do we make this unwind? Well, there are probably different ways of doing it, but I found the easiest way was in the Mesh Distribute node, the very first node here. And if we go down to the strength attributes and we turn off scale and position and then just animate the strength, it's acting only on the rotation, and we get this kind of nice unwinding animation down to 0. So let's just animate that. So let's start at, I don't know, frame 24. We're working at 24 frames per second here. Set a key on strength, and then let's give it just 1 second to unwind and set a key. Let's play that back. Right, so that's pretty good. So you can see a couple of problems here. Now the orientation of the backbone is a bit weird, but because we added that offset earlier, and I'm going to call this BBROT. Let's play this back. Right, so as that's happening, and you could retime that to make it a little less imperfect, not really more perfect, but I get that. And now we still have that angled kink from the replicator, so we'll just animate that at the same time. Go to frame 24, and the rotate replicants, remember I set to 133 or 120. I'm going to set a key here. And then at frame 48, I'll just take this down to, or bring it to 180. Is that right? Yep. And I'll set a key on this. Okay, so we're almost there. It's doing what we want. Now we want it to open up. So we're going to add an offset node here. So we'll add another offset, and we'll call this Unzip. And here we don't want to offset rotation or scale, but just position. And we want it to move, let's say, open up 2 units. Now you see what happens here is it actually moves the entire MASH network up 2 units. It offsets it. But the thing to remember about MASH is that it has an order of operations here in the MASH editor. And if you don't have this open, you can go to MASH editor and open it there. And it does its operations from the bottom. So distribute first, then offset the rotation, then the replicator, and then the unzip. So if we just drag this unzip below the replicator, then it will open up after the offset before the second one is created, and then the offset will be applied to both separately in opposite directions because of the rotation of the replicant. So that's pretty good, right? And it's almost what we want. So let's say, this is kind of cool actually. So, you could animate them separating simply by animating this 2 offset position, or the strength here. You could animate that, but that's animating the whole thing at once. We want it to unzip along the length. And to do that, we're going to use a falloff object. So if in the offset node, the unzip offset node, falloff object, right click and say create. And so it creates this big shape. And you can see that now this offset node, the effects of it are only felt within this falloff object. So the falloff object has an outer range and it's got this inner zone, and then the effects fall off between there. So if we just go down here and double click on this, can open it in the attribute editor, and we can reduce the size of the inner zone to 0 so we get a more gradual change. So that's looking pretty good. And you can change the Falloff Ramp here if you want to. You can add more points if you want to change the nature of the transition. So there are lots of things you can do. And then I'll just take this over here, and to do the unzipping, let's start it at frame 60. We'll just key the position of this falloff object. So let's start at -11. Actually, I'm going to send it back a little farther because I'm going to add one more falloff node in a bit. So -15, we'll set a key on that. And then let's say over around 24 frames, another second, this will come in and unzip part of the DNA. Let's give it a nice clean number, 15. Set a key. So it unwinds, opens up. Now, you'll notice that it opens up but then closes again after. And that's a quality of how the Falloff node works. So if we open the Falloff node in the attribute editor again, there's some other settings here. So there's Invert, which could actually be useful in some cases if you just wanted one part closed and other parts open. You can change the shape to a cube, NURBS curve, particles even, or even a mesh object. So if you had some sort of molecular structure here and you wanted it to influence the effect on the mesh, you could use mesh here. We're going to stick to sphere, but this is what we want to change, the mode. So normal means that the effects are only felt within here, and then when this fall off object moves past, things go back to normal. And this is usually the way you would use this, but you can also change this to add. And if we play this back again, you'll see that the effects are added to the mesh and then they stay there. So now it stays open. Oops. So the last thing I want to try and correct is the angle of these ones here. I added one more offset node, and I'm going to call this unzip correction. And we're going to enable rotation only. Let's do -20. Right, so that's better here, like that's nicely lined up. And we can use a fall off object again. Now, if you wanted to, you could just middle mouse drag this fall off object into this region to make a connection and use the same fall off object. But I don't want this fall off object to be set to add. I want it set to normal so the effects are only within here. So I'm just going to create a new one. Something like this. Can't for some reason scale on screen, so I'm just going to change it to this, and you'll see this is really not a perfect solution, but it's not too bad. So let's say something like that. That looks pretty good. Now I'm just going to parent this to my original one. So now it's a child, so I just middle mouse dragged it onto the original. So we'll just have the same animation and just be a little bit in front of it. Actually, this works better than the one I tried earlier. That's pretty good. Not perfect, but it's pretty good. Save my scene. Okay, so far so good. Now let's just add a little je ne sais quoi. We'll add a spring node, and this just adds some secondary motion. And I'll play it once and you'll see it's all wonky. Right? See all this jittery? But that is nice motion there. We don't want to spring the rotation or the scale. We just want we just want the position. Right, so that's nice. I change this to, can't go past to maximum translation. So you could play around with these things. So this is the most it could go. Damping, if you reduce that, it will last a little longer. Okay, so we're almost there. The last thing we're going to add is a signal node. Perfect. No, just kidding. So the signal node just adds a little random animation. And this you don't need necessarily, but you can see it breaks it up because by default, the signal node is set to enable step. And that means that the noise is applied to each one of these instances separately. We'll turn that off, and now it's an overall noise that's applied sort of continuously over the whole population. So if we play the animation now, we get something like this. It's a little too much, so I can just reduce the noise scale and even the time scale just to slow it down, just to add a little bit. And then finally, what I think I'll do is I'll just move the spring on top, so the signal noise will actually have some secondary motion too. So anyway, make sure your DNA is coiling in the right direction. Make sure your dimensions are correct, and just have fun making DNA. Thanks.